Okay, in this video, I'm just going to show you how to use the equivalent resistance interactive in case you need a video to help you with this. So when you open up your document, you're going to click on that link, and it should take you to something that looks like this, equivalent resistance version 2.1. Click on the start button. You're going to use this as a guest, so we don't have a subscription to this service, but we can still access it as a guest. So just click on Start Activity. And I already did a couple of these things for a different class, but for recording of this video, I'm just going to go ahead and show you how to do one or two of these other ones. And so let's just click on level 2 here for a second. Your goal is to try to determine what these resistor values need to be in order for the equivalent resistance to be 36 ohms. So obviously if I put in 36 for each one of these things, they would not add up to giving me an equivalent of 36. I have to figure out what values I would use here. I know that for things in series, the equivalent resistance is just the sum of these things. And again, that goes to the idea that resistance is resistivity times L over A. This is effectively making the length of the path 3 times longer than a single one. I would say that each one of these resistors is 12 ohms, and that should get me to the equivalent of 36. Click on Check It, and sure enough, it gives me a star for that one. Let's take a look at level 11. Now this is a combination circuit. It has a series of 2 resistors in parallel that are in series with another resistor here. I need to get an equivalent resistance of 7. Now down here I have 3, 6, 7, 12, and 14 that I could choose. Now let's just think about this for a second. If I made each of these 2 resistors, if I made each of them 14, then that would give me an equivalent of 7, but I have to have some resistor here, so it clearly cannot be 14 ohms for that. So I need to get to something that would then provide this plus that to be 7. Now, let's try this. Let's say I made these things be 12 ohms each. So 12 and 12, that would give me the equivalent of 6 ohms. And there's not a 1 ohm down here, so that wouldn't work. Let's see if I make this one be 6 ohms. And I make this one be 6 ohms. And I say, okay, based on that, these 2 together would give me 3 ohms of resistance. And 3 added to, I don't have a 4 down here. So I can't even do that. And so it looks like I'm going to have to relook at this one to see if I can't figure out a different set of numbers here to give me, in parallel, to give me, when added with this one in series, to give me 7. So it clearly is not going to work with these things being the same. Okay, so I'm going to go ahead and just say that this one is 7 ohms. I know it's not going to work because this would be 3, and that'd be 7, that'd be 10, and that's not going to work. I'm going to say check it. I got it wrong, and so it's going to go back and it's going to give me an option to be able to try that one again. Okay, so something maybe with some slightly different numbers. Okay, so this is going to be a little bit more challenging than what we originally had thought with these things being equivalent. All right, let's just see if we can't figure out a way of doing this. If I do 3 and 6 together, 3 and 6 together. I don't think that would work. 3 and 6, let's see, it'd be 1 over 3 plus 1 over 6, add them together. This would be an equivalent resistance 3 and 6 to be 2. And you can verify that that's right with some math there. But 2, I don't have a 5 here, so it can't be that one. Let's try this to be 6, try this to be 12 and 6 and see if that would do it. I'm going to have to use a calculator to be able to go through and check that one. So if I had 12 and 6, that would give me an equivalent resistance of 4. So let's just check that. I'm going to put that one in as 12, put that one in as 6. These 2 together, if I did 1 over 12 plus 1 over 6 and then take the reciprocal of that, that would give me a resistance of 4. So these 2 together would be an equivalent of 4. And I do have a 3 ohm here, so I can put a 3 in on that one, and I check that, and sure enough, that gave me the correct answer for that. So the idea here is if you get it wrong, it's just going to say, sorry, try it again, and it's going to give you another problem that's very similar to that one that you're just going to have to figure out how to get through that. And so your goal is to complete all 18 of these, and then take a screenshot. Now what I don't know, and this is something for you to be cautious of, is once you finish this last one, I hope that it will continue to allow you to see this screen. So sometimes acting as a guest, once you complete that last one, it doesn't take you back to this thing here and you don't have a completed picture. So maybe just by chance, take a screenshot after you've got number 17 done, and then in the event that you don't have access to the screen after you've completed 18, you can just turn in the one that has 17 with the star. Okay? I hope this video helps.